Okay, good morning. Good morning. What I want to continue with today is series and parallel circuits continued. Now, series and parallel circuits is quite a large area of subject, and you need to be familiar with resistors in series and parallel and to be able to calculate those values for yourselves. Now, some of you will be doing an apprenticeship. So when you're doing your apprenticeship, remember that your apprenticeship is not just for the 5 years that you're doing the 4 years that you're doing your apprenticeship for. It's okay, mine was 5. But it's a lifetime acquisition that you're actually achieving. And once you have been qualified as an electrician within those 4 year period, you're qualified for life. Yes, you're going to have to update your knowledge maybe every 5 years or so, depending on what area you're in. But if you're doing domestic, commercial, industrial installation, whether you work for the national grid, you are set for life as an apprentice. Once you have achieved an apprenticeship criteria, you're set for life. It doesn't matter what economic situation occurs, you will still be able to survive or to diversify into another area that you never thought of before. So remember that it's not just learning for now, it's learning for the future and your own future development that will matter to you. Okay? That is all I can say. I can only tell you what I know and what I have experienced myself. And I am very glad that I served an apprenticeship. And my time, served my apprenticeship was the 236 City and Guilds, Part A, B, and C in my time. Okay, I only got up to Part A, did a bit of Part B, but as time went on, I realized that I needed to do more for myself. Because nobody's going to do it for you. You have to do it for yourself. You have to get up in the morning, go to work. You have to get up on the Wednesday morning, be at college on time, 9 o'clock. Don't bother rolling in there at 9:30 or anything of the sort. That is a waste of time. Not only are you wasting your own time, but you're disturbing other people who are there to learn. And some companies pay some big money for their students to go to college to educate them because it is an investment, a long-term investment that matters very, very much. So don't think that you're going to college and how boring it is. Utilize it, make the most of it because it shapes your life from here on. Okay? Right, let me stop talk and I'm going to get back to work. So you're not going to see what I'm doing, but you'll need to look at, let me just reconfirm that for myself. Series and parallel circuits continued, okay? I repeat, series and parallel circuits continued. That's the one you'll need to look at, okay? In regards to this edification, okay? Right, let me just, bear with me. Okay, I've got you set up. Okay, okay. I did, I did, I did. I'm sort of got really cancel, yeah. Yeah. Now, funnily enough, my camera was playing up with me the other day. And he didn't want to do as he was told. So I had to give it two blinking, two smacks. He did a little bit of weeping and crying, first of all, but it did as I wanted it to do in the end. Okay, Okay, we look like we're in business. Look like we're in business. Hang on a second, let me just get my framework up in correctly. Okay. Okay. Pan back. Now, one of the things I noticed the other, I did a video and all it looked like it was all on screen. When I ran it back, it was half the top was missing, and I don't actually know how that came about. But to make sure I minimize that, I'm going to pan back once I've started and finish. Okay. Okay, let me just go back to where I am and count my instructions. Right. Series and parallel circuits continued, and you would look at that from the perspective of some continuation work that I've done already, which you will see on my channel, okay? Here we're looking at understanding the relationship between resistance, resistivity, voltage, current, and power, okay? Pure revision here. Okay, I don't need to do anything further on this. Electricity is considered to be a flow of electrons. Current is the rate at which electricity flows around a circuit. Resistance is measured in ohms and its symbol is the omega. Electrical resistance is a measure of the degree to which an object opposes the passage of an electric current. Each material has its own specific resistance. If the material changes in size or area, it will change its resistance. P rho is the symbol used for resistivity. Any electrical circuit requires three things: a source, a load, and a means of transmission. The source provides an electromotive force, or EMF, to the circuit. George Ohm discovered that the resistance of the conductor is linked with the voltage to the current. Okay, pan back, make sure that I can get it in because I do not want you going over my head in any shape or form. Okay. It's all right. You gotta talk to camera sometimes because it never does all this blinking told. Okay. And here, for me, this is session 5, series and parallel circuits. In this session, the students will have the opportunity to apply Ohm's law to series and parallel circuits. Okay. Series circuits. Now here we have when more than one resistor or load is connected to end, then they are said to be connected in series. Here we have 1, 2, 3, 4, 5 resistors connected in series. To the end simply means any number. Okay. Here are your codings. Okay. Your codings. Here we have brown, black, red. Okay. Now, I don't remember the colors offhand directly, but I think brown is 1, black is 0, something or the other, and red is 2. But don't hold me to it. I'm just spouting off. It's up to you to make sure that you investigate the color codings correct and that you know the values for yourself. Okay. Here we are. Okay, again, similar thing you would have seen earlier in the other session. Okay, except that this is just recapping on it. Okay, so we're just simply doing a bit of recapping. And similar thing here as well. Okay. And here they're just showing you what they did to get resistance total. Okay. And in series, the resistance is the same in any component. The current is the same in any component. Apologies, the current is the same in any component. So okay, I was thinking something else for a moment there then. Parallel circuit, okay. You're familiar with this, so I don't need to spend too long talking to you on this, okay? Well, my apologies again. I have to assume that your new parallel circuit is one where all resistors have the same voltage across them, okay? In a parallel circuit, the voltage across the loads are constant, and it is the current that divides. Voltage applied to each resistor in a parallel circuit, irrespective of the size of the resistor, is the same, okay? Current flowing in a parallel circuit, okay? And here, the total current is the sum of the current in each of the legs in the network, okay? So the current would be R1, R2. The voltage across the circuit, the parallel circuit, is the same, but the current in each case would be different. I don't think we can ever do enough on Ohm's law, and that is important to keep that in mind, okay? I equals V over R, or I equals U over R, okay? V for me is I'm old fashioned, okay? But U is for you because you're now young and up to date, okay? Multiple choice questions, okay? Make sure you have got these, okay? Use the information given, okay? You can read for yourselves and make sure that they're quite there. Thank you for your time. I hope you will find this useful. Have a good day. Bye-bye. Okay. Okay. All right, let's bring it to a close. Thank you.